Today we're going to talk about the number system. There are lots of vocabulary in the number system, and it's really important that you understand what each of the categories are in the system name. So the number system that we deal with in math compromises lots of pieces, and we can categorize numbers in very specific terms or very general terms. So we're going to talk about first the real number system. So the real number system is the combination of both rational and irrational numbers. And you'll learn a little bit more about what rational and irrational means. So examples of real numbers, -1, 0, a half, square root of 3, pi, those are all real numbers. Now, in our number system, we have real numbers and non-real numbers. And non-real numbers we'll touch on at the bottom of the definitions. We don't use non-real numbers very much at this level of math, but you do need to know that when you get something that doesn't fit into one of these categories, doesn't mean it's not a number. It just has a different fit. It actually is one that's kind of, think about it as an outer space. It kind of flies out there on its own. It has its own set of rules. It's still part of the number system, but it's not the real numbers. So the little r here that has kind of the double side is the notation they use to notate the real number system. So you may see that and then a list of numbers, so you know whatever they're saying is a set of real numbers. So do know that what that notation means. All right, our second word is rational numbers. So we're going to talk about rational and irrational, but the rational numbers are numbers which can be expressed as a fraction. So it's important to know that they can be written as a fraction. As decimals, they will repeat or they'll terminate. So for example, 4 is a rational number. It can be written as a fraction by just putting it over 1. 3/4 is a fraction. It's a ratio. It's can be written as a decimal as 0.75. And if it's written as a decimal as 0.75 or 75 hundredths, it terminates, it ends. We know it stops after 5. It's done. 0.33 with the little line above it's telling me that 3 is repeating. This is the same thing as 1/3. We know when we write that as a fraction, we can write it, and we know that as a decimal, it goes on forever and ever with a pattern. So it's one of those that has a repeating pattern, but it has to have a pattern that repeats. Now, something to remember is that the textbook definition in math you'll see is A over B, where A and B are both integers, and B is not a 0. So what that means is I can have a number like 3/4, and 3 would be considered my A, and 4 would be considered my B, and they're integers, and B is not a 0. So what would happen if I had a 0? So 3 divided by 0, we know that I can't take a number and divide by 0. That would give me an error in a calculator. That's an undefined number. And in that situation, it's not rational, but it's a non-real number. Those are ones that it's undefined, so it's in that imaginary world, that non-real world out in outer space. So we got to remember that. We can't do this. Now, a little short, quick cut to remember is rational. The root of that is ratio. Ratio helps us lead to, we know ratios are fractions. So we know that rational can be written as fractions. The symbol for rational numbers is a Q, capital Q. All right, irrational are numbers that cannot be expressed as fractions or in a ratio. When they are decimals, written as decimals, they never repeat. It means they don't have a pattern. They may go on forever and ever, but they don't have a pattern. And so we think about something that just goes on and on. We think about somebody that, maybe drops their ice cream and they just go on and on and on about it and just act kind of crazy. We think, oh, they're being very irrational. Well, irrational numbers are the same way. It's like pi, 3.1419, and we can keep going forever and ever and ever. Doesn't have a pattern. It never ends. The square root of 2, that's not a perfect square. If we put that in our calculator, it almost looks like it ends, but it doesn't have a pattern. It actually stops on the calculator because there's no more room for any more numbers to go. So we know that's not a perfect square, so it is irrational. And then this example, decimal 34, 33, 434, 333, it almost looks like it has a pattern, but it doesn't. So it's irrational. And the little dots mean it's continuing to go. We represent these with a Q with a little 1 above it, and we say this as Q prime. So this little number we say as prime. and that tells us that something else has happened. That's just the opposite of our rational is irrational. Then our next word is integers. Integers we've dealt with already. They're both positive and negative whole numbers, including 0. So we have -3, -2, -1, and their opposites 1, 2, 3, and of course 0. And these can go on in each direction. Remember, they're whole numbers. They can still be written as fractions, so they still fit into our rational numbers, and we'll talk about categorizing shortly. But the symbol that we use for integers is a Z, a capital Z there highlighted. Our next level is whole numbers, or sometimes people call them counting numbers without the 0, or with the 0, excuse me, with the 0. So whole numbers are 0, 1, 2, 3, 4. They're all the positive numbers, and we categorize those or label those with a big W, so a capital W. Our last level is natural numbers. A lot of times people call them just counting numbers, but natural numbers are numbers we use to count, so 0 is not included. So think about when you were little and you learned how to count. We didn't count with 0, 1, 2. We started with there's 1, 2, 3, 4, and so on. So these are whole numbers that we use to count, but 0 is not included in those. We use a capital N to show how we that those would be natural numbers. All right, and then we talked a little bit about non-real numbers. Non-real numbers are imaginary numbers. They're roots of negative numbers, and they're undefined. And the biggest thing to remember is they do not fit on a number line. There's nowhere, we don't know where to put them because they don't end. They kind of don't really fit anywhere. So an I is what you get when you deal with negative square roots. We have a negative square root of 2 there, or square root of -2. If you put that in your calculator, it's going to tell you there's non-real number there. The infinity, we know that goes on forever and ever. It doesn't fit anywhere. We don't know where to put it on a number line. And then 3 divided by 0 is an example. We can't divide by 0. That would be undefined on our calculator. So remembering that non-real numbers cannot fit on a number line will help you. So we're going to use a graphic organizer here, and we're going to classify a few numbers and talk about where they can go. So when you look at this graphic organizer, think of a big box. Some people use circles. So the whole thing here is the real number system, and then out to the side we have some non-real numbers. They're kind of hanging out. They don't belong in our real number system. They're on the outside. They're still in the number system, but not in the real numbers. So all of the things we're going to talk about are real numbers here, and we have rational and irrational. Those are two big, broad topics. So when you look at a number first, you're going to ask yourself, is it rational or irrational? So irrational, we know, cannot be written as a fraction, where rational numbers can. So let's start with number 4. So the number 4, can we write it as a fraction? Yeah, 4 over 1. So we know it's rational. Okay? We can go further. If it's rational, we can go further and see, is it an integer? Well, yeah, integers are positive, negative, whole numbers. So it also can fit in the integer category. Is it a whole number? Yes, it's a whole number. 4 whole pieces. And is it a natural number or a counting number? Do we count things? Can we go 1, 2, 3, 4? Yes, we can. So it is a number, very specifically. It's a natural number, but it could live in the neighborhood of whole, integer, or rational, and it lives in the real number system. So it fits in all of these categories. All right, let's look at 1/3. 1/3. Can it be written as a fraction? Well, it already is, so we know it can be a rational. We know it's not irrational, we know it's rational. So it's a rational real number right now, and then we look further. Can 1/3 be considered an integer? No. If it cannot be considered an integer, it can't be a whole number and it can't be a natural number, so it stops right there at rational. Let's look at 0. Can 0 be written as a fraction? Yeah, we can put any number over 1, and that doesn't change it. It's still a 0, so it can go into the rational. And then we ask ourselves, is it an integer? Well, it's counting numbers and their opposites, so yes, it's an integer. Is it a whole number? Yes, it's not negative, so it's a whole number. Is it a natural or counting number? No, it cannot be used to count. We don't say 0, 1, 2. We start counting with 1. 0 is not included in natural. So for 0, it can live in the whole community. It can live in the integer community, the rational, which is all in the real number system. So specifically, if we want to get to the very clear point of how far it can go all the way to the whole number system. before we can, or the whole numbers before we can say it can't go any further. It can't move out of the whole numbers to natural numbers. It's got to stay either in that community or integers or rationals in the real world number system. All right, let's look at pi. Can pi be written as a fraction? Well, we could put it over 1, but let's think about what pi is. Pi is one of those numbers, is 3.1419 and da-da-da-da-da. It goes on forever and ever. There's no pattern. People are constantly finding new numbers. So pi is actually irrational. It's in the real number system, but it's irrational. It cannot fit anywhere else. It can't go visit rational world. It can't go visit integers, wholes, or naturals. And it can't go outside the world because it is an irrational real number. So that's as far as it can go. All right, let's look at the square root of 16. So the square root of 16, we think about what is that really? What times itself gets me 16? Well, I know that's 4. Well, we've already placed 4 in our rational, integer, whole, and natural, and we know that that's a real number. So it can live, the square root of 16, can live all the way down here. So don't be confused just because it's not written the way you think it should be written, that it can't fit. Think about what it actually is equivalent to. So this can actually fit everywhere. Now let's look at the cube root of -8. Remember, cube roots can be negatives. So what number times itself can get me a -8? Well, if I think about it, -2 times -2 times -2. So I know this is the same thing as a -2. So is a -2, can it be written as a fraction? Yes, we can put it over a 1. It's a fraction. So we know it's rational. Then we go further. Is it an integer? Yes, it's an integer, because it's negative and positive numbers, whole numbers are integers. Is it a whole number? Not if it's negative. So negative numbers cannot go in the whole. So as far as -2 can go, it can go to the integer world, it can go to the rational neighborhood, it's all in the real number system. So most specifically, we can call it an integer. So you'll have the chance to work with other numbers. Now I do want to add a couple of non-real numbers to our little table here. We had some up front, but we know that these are an I for imaginary, or our 3/0 because we can't divide by 0. Maybe our infinity sign, we can't fit that on a number line, and anytime we have a square root of a negative number, we also know that that is a non-real number. All right, so you gotta have a little practice to do. So jump into the number system.